one of the situations where we're actually going to have to integrate. So 31, y equals sine, y equals cosine. I think it was y equals 0 and x equal pi over 4, was it? Or was x equals 0? I guess y equals 0.
X equals 0, right?
20, 31, x equals 0 and x equal pi over 4. So I will rely on your previous knowledge of trigonometry and assume that you can draw the sine. If that's 1, then pi over 2 is roughly here. So pi over 4 is roughly here. Sine and cosine are equal at pi over 4. Right? The sine of pi over 4 equal the cosine of pi over 4 is rad 2 over 2, which is about 0.7, just very roughly. So we have a point of intersection roughly there. We know that the sine starts at the origin and continues on, right, to max out at pi over 2. So evidently this is kind of what the sine looks like. The cosine, we know at 0 maxes out at 1 and then becomes 0 at pi over 2, so it's kind of like this. Okay? So my artwork is, well, should I say not great? I think we know it's worse than that. But my knowledge of trig is not so bad. And I know that the cosine and the sine are the same curves, just translated from each other. So no one needs to tell me what x bar is. Nor do they need to tell you. The line of symmetry. Right? They're both maxing, they're equal here, distances equal, so I know that x bar has to be there somewhere. Y bar is the only thing I have to find out. Okay. Questions? You gotta see the look. Some of you guys are giving that little diagram just because I can't draw well. Yeah? Oh, I was doing it at x equal pi over 2. That's right. If we do x equal pi over 2. Yeah, x equal pi over 4 means I don't have that, do I? I get, here's x equal pi over 4. Now remember I wrote y equals 0. I had y equals 0 on mine, didn't I? There's x equals 0. And so the cosine, oh man, so there's no symmetry at all. Aw, shucks. So I've got to draw that solid and that dotted. Too bad. Well, anyway, I think you should pay attention to the one that I just did before that, because that's the thing that I would not be unlikely to do on the exam, where you would be able to discern a line of symmetry and therefore find at least one of the coordinates of the centroid. So unfortunately here, they've been, well, not nice. So we're trying to find the centroid of that region, which you can guess, right? It looks like somewhere around there, just as a guess. And we have two formulas. I guess the first thing I need is the area. Both formulas call for the area. How shall I get the area? It's 0 to pi over 4. So cosine minus the sine. So that's sine x plus cosine x, 0 to pi over 4. Is that correct? Yes. So rad 2 over 2 plus rad 2 over 2 minus 0 plus 1 is rad 2 minus 1. That's the area. Now x bar is going to be the integral from 0 to pi over 4 x. Well, we're going to have to, on this one, since there's two equations, take cosine x minus the sine x dx. And divide by the area, and the area is rad 2 minus 1. Okay, so how do I go about doing that integration? And u equals, and dv is? He sees clearly, does he not? du is dx, and v is the integral of that junk, which I think we just did, didn't we? Sine x plus cosine x. So, x bar equals u times v, so x sine x plus cosine x, minus the integral of v du, so integral 0, well, we're going to evaluate all this from 0 to pi over 4. v du is sine x plus cosine x dx. This is all from 0 to pi over 4. And the denominator is a rad 2 minus 1. So, continuing to integrate, x bar is x sine x plus cosine x minus cosine x plus sine x from 0 to pi over 4. And it's all over, and it's all 0 to pi over 4, isn't it? So let's make that minus and minus, that becomes a plus, that becomes a minus, right? We'll go ahead and distribute the minus sign. Rad 2 minus 1. And now if we let x equal pi over 4, we get pi over 4 times rad 2 over 2 plus rad 2 over 2, plus rad 2 over 2 minus rad 2 over 2. All of that was what was happening when we plugged in pi over 4. Now subtract, plug in 0, and you get 0 plus 1 minus 0, all divided by rad 2 minus 1. So, of course, these two guys annihilate each other, don't they? Right? It's going to go to 0. This is pi rad 2 over 4. Minus 1 over rad 2 minus 1. So, I don't know, I imagine they want a decimal approximation on this one. It might be worthwhile to at least get rid of the compound nature of the fraction. That makes it pi rad 2 minus 4 over 4 rad 2 minus 4. So notice the denominator is bigger than the top, isn't it? Right? These multiples are the same. These things we subtract off are the same. Pi is a little smaller than 4. So I can see I've got something smaller than 1. Well, this is 0.75, so hopefully I'm at least close here. But now it's a job for someone with a calculator.
0.26.
What'd you get?
0.26.
That seems.
I would think it would be a
Yeah,
little
bigger.
closer to 1 than that, but maybe you're right. Certainly that's what I've drawn there, huh? If this is approximately 3 over 4, because pi is approximately 3, so that's about 0.76 or something. Then what I've drawn here is about a third of that. So what did you come up with?
0.26.
So about 0.26. Actually looks like about what I drew. How do I calculate y bar? Well, that is going to be the integral from 0 to pi. I'll let somebody else make sure and double check this calculation. 0.095?
I got 2.27.
.95 would be unfortunate if I got that, because that is clearly over here.
Yeah, I got .27.
0.27.
Okay. So I have several people with a .27. So y bar is going to be 0 to pi over 4, 1/2, and we're going to have cosine squared x minus sine squared x dx. Well, that was a lot less pleasant of an integral to do, isn't it? The denominator is rad 2 minus 1.
Because top.
Top minus the bottom.
Top minus.
Same as I would on an area. All right, so I should ask myself if there's some nice clever thing I can do that will simplify that. That's a double angle formula for the cosine, isn't it? So they actually, it didn't look like it, but they actually were kind of nice. That's cosine 2x. So that's fairly easy to integrate. I think that's going to be 1/4 sine 2x, all evaluated 0 to pi over 4, divided by rad 2 minus 1. 2 times pi over 4 is pi over 2. So yeah, I've got 1/4 times 1 minus 0 all over rad 2 minus 1, so that's 1/4 times rad 2 minus 1. And hopefully that's going to come out to be about 0.6 or 7 or something like that. Maybe my drawing is skewed. I think that's going to come out to be, what does it come out to be?
0.6.
Oh, well, good. Well, rad 2 is about 1.4, so this is like 1/1.6, so that's about 10. Oh, you made me do the calculation myself. This is what you get. So this is about 5/8, so that's about 0.6.
0.6.
So there. She's forced my hand. So that was fun. Let's do a theorem of Pappus. How about the number? Oh yeah, I want to do that one. I guess let's first of all do 46, as if we haven't done enough triangle work. So 46, they give me 3 points. What are they?
2,3, 2,5, and 5,1.
And what's the, what are we rotating this about? So y equals 0. So in other words, they want us to take the triangle defined by those 3 points and rotate it around the x-axis. And they do not want me to do the shell method. They do not want me to do the disk method. They want me to use the theorem of Pappus. If I had been given a choice, I would have chosen that. So 2, 3. 2, 3 and 2, 5 are vertically stacked, one above the other. 5, 4. Wasn't that nice of them? Oh, that's just exactly the dirty, rotten, kind of lousy little trick I'll play on you so that I can really rub your nose in it if you don't get it. That was really easy of them, now wasn't it?
Mm-hmm.
How come?
They're equal. Two sides is equal.
What do I need in order to use the theorem of Pappus? If they're going to rotate this, they're going to be creating some sort of a weird little cylinder here, huh?
You need the area of that.
So the area is very easy to compute, isn't it? After all, it's composed of two little right triangles there, isn't it? As soon as I get the area of that one right triangle, I'll double it and have the area of the isosceles. Well, that's 1. What's that?
4.
From 2 to 5?
4.
3.
So the area is 1/2 base times height, but we have 2 of them, right? So the area is 3. Somebody gonna tell me why I didn't need that at all? Just wanted to do the calculation. Well, what I'm gonna do is take the centroid and look at the distance. Well, I guess I did need the area. Did need the area. I was thinking of finding it for the centroid, but I need the area, so that's right. It's 3. Tell me why I don't need any calculus to do this problem, though.
Area times distance.
I'm going to rotate it around the x-axis. So the centroid is going to be wherever it is down to the x-axis, isn't it? But we don't need calculus to see what the y-coordinate of the centroid is, and that's all I'm interested in. I don't care where the x is. It's the y height of the centroid that will give me the radius of the circle. Well, I know that since there is a line of symmetry, y bar is going to be right on that line of symmetry. So I can, by observation here, see that y bar is 4. Right there. Cuts that isosceles triangle into 2 congruent pieces, notwithstanding lousy drawing. So the volume is going to be the area of the region times the distance traveled by the centroid, which is 2 times pi times r. So 24 pi cubic units will be that volume. If I don't give you a situation like that, or if I had rotated it around the y-axis, if I had rotated it around the y-axis, now you need x bar. X bar is not on a line of symmetry. You would have to calculate x bar, either through geometry or through calculus. So if you're going to use calculus, how do you calculate x bar? First of all, we're going to divide it by the area, which we already know is 3, and it's going to be the integral from 2 to 5. Let me draw that in a different color. So x bar is going to be the integral from 2 to 5. We're going to divide by 3. Well, I need this equation. That's a line. It's going through the 2 points 2, 5 and 5, 4.
Could you use any? Like along the bottom one?
Well, I'm going to need the bottom too. Right at the top, the equation, well, the slope is a minus 1/2, isn't it? Right, so y minus 5 is minus 1/2 times x minus 2. And the other line has a slope of plus 1/2. And here's the point 2, 3. So that's y minus 5 equals plus 1/2 times x minus 2. So the two linear equations are y equals minus 1/2 x. This one's going to be plus 1 plus 5. And here y equal positive 1/2 x. That's minus 1 plus 5. So I'm going to take the integral from 2 to 5 to calculate x bar. What is that?
Yeah.
Should be there.
Well, down 1 and over, 3, sorry. Oh, so it doesn't come out to be nice numbers. Well, anyway, pretend it was 1/2. So I'll let you calculate what the numbers are. But in any case.
Can we write that on the
this-
test?
yeah,
Pretend
you
your
do that.
question was this.
Pretend your question was that. So yeah, then you're gonna take, let's see, I believe it's x times y1 minus y2. Yeah. All right, where y1 is the line on top and y2 is the line on bottom. Yeah,
Could we took those 3 points as 3 masses with same mass, then their mass cancel. We can find this simpler.
yeah, you could use but remember what I was asked, what I was doing, was finding it using calculator.
Yeah.
That was one. But otherwise, you could just use the finite number of points. And failing that, you don't need to do that at all. You can use the geometry. Okay. Number of, and hopefully you don't need to do any of that. You can do just like the problem was originally set up. So, let me see. I believe we need to talk a little bit about 9.3, right? There was some fun problems.